AP Statistics, Lesson 2.2, Graphical Displays of Distribution. Our learning goal in this lesson is that we will be able to construct and use several types of data displays. And the question I want you to be asking yourselves throughout this is, what does the data look like? We have some vocabulary, as usual, quite a bit actually. First one is quantitative, qualitative, or categorical. Those are synonyms, and they are used interchangeably. Dot plot, histogram, frequency, bins, classes, or intervals. Once again, those are synonyms that are used interchangeably. Relative frequency, stem plot, bar chart, cases, variable, and univariate. Okay, we will be looking mostly right now, actually for this whole chapter, we're looking at univariate data. And that's data that measures the frequency of just one single variable. And as we've talked about it before, we've got cases, and the cases are the things that we're measuring, and the data points are what we measured. Okay. So, first thing that we have already been using is a dot plot. And dot plots are good for relatively small sets of data. Like, I wouldn't want to put more than 300 or so on a single dot plot. They're also good because you can usually see the individual values. It shows the distribution shape, and it organizes data. And we've used these before. We know what they look like. Here is a relatively small set of data on a dot plot. And we can kind of see it's somewhat normal. There's a big gap here. So you can see the data that way. Okay. Histogram. This is relatively new. This is a histogram. It divides our range into equal intervals, and those are sometimes called bins or classes. In our book, they call them bins. Other books call them classes. I still usually call them intervals. But the main thing is that they are equal. It has heights of, the height of the bar indicates the frequency, and it's kind of similar to the number of dots in a dot plot. And the frequency is also always on the vertical axis. Histograms show shape. They also show center and spread, and they're really good for large sets of data. But you can use them for... So we are going to make a histogram. And I have a data set of mammal speeds. And the thing about a histogram or a bar chart is that I really can't see how big my bars are going to be until I make a frequency chart. So I have to kind of organize my data first. And I'm going to have my bins and my frequencies. Now, I have to come up with the width of my bins. And the way I do that, and there is no one right answer here, so if yours doesn't look exactly like mine, that's okay. The main thing is that you have bins that are of equal space, and they cover your entire range. So my range goes from 11 to 70, and that's about 60, and I want 5 or 6 bins. So I'm thinking breaking 60 into equal parts, maybe by 15. So I'm going to start at 10 because I like using round numbers. 10 plus 15, go up 15. The next one would be 25, which means my bin before it ends at 24. And I go from 25 to 39, 40 to 54, 55 to, it's almost 70, 69, 70 to 84. So in each of my bins, there are 15 values. Now I could have started at 11 and probably ended up with one less bin, but that's okay. That's okay. So I'm going to look at my frequency in each of these. So between 11 and 24, I have 1, 2, 3, 3. And then between 25 and 39, I have 1, 2, 3, 4, 5, 6, 7. And then 40 to 54, 1, 2, 3, 4, 5, 6, 7. And from 55 to 69, I have 0. And then 70 to 84, I have 1. Okay, so that is going to be the frequency I'm going to use on my bar chart, or my histogram, excuse me. So the frequencies always go on the vertical scale. And 1, 2, this is a good place to get out the graph paper if you would like to, because you can be like me and end up with uneven frequencies, or you can have nice even ones if you use graph paper. Okay, and on the bottom we have our bins, and a lot of times they use the midpoint to get the middle of the bin, or they just use the edges. So I'm going to go 10, 25, 40, 55, 70, and then the next one would be 85. Okay, so the main thing is it covers the whole range and is equal. So we go up to 3. We make our bars equal to our frequency. This one goes up to 7. This one also goes to 7. And depending on where you would put your bars, you might have something that the frequency looks a little bit different than that. But this gives you a general idea. You might want to make smaller widths, like maybe by 5s, or you might want to make larger widths, like by 20s. It's kind of up to you. Okay, so anyway, this is our histogram. If we were going to make a relative frequency histogram, we would have to figure out the relative frequency. So here we are. Relative frequency is often used to compare the bin to the whole data. It also, if I had like maybe mammals compared to reptiles or birds or something like that, I might have, it's better to put it in relative frequency because I might not have 18 birds or 18 reptiles. I might have more or less. So that is when it becomes easy to do relative frequency. So I am going to just divide my frequency by the total number of points. And in this case, we have 18. So I'm going to divide each of these by 18. So 3, get the calculator up here, on 3 divided by 18 is, now in this case I'm going to round to the nearest third digit, because really you want 3 digits. 7 divided by 18. And many times they aren't pretty, like these are not very pretty. That's also 7. 0 divided by 18 is 0. That's nice. And then 1 divided by 18 is 0.056. Okay. So, and if I did this right, these should all add up to 1, although they're not going to always be exactly 1. Let's see what we got here. Okay, 0.167 plus 0.389 plus 0.389 plus 0.056. I'm going to leave the... See, we ended up with 1.001, and that's okay. That's close enough, because since we did all that rounding, and most of the time we rounded up, we're a little bit high, but not enough to make a difference. So we are going to go ahead and put in our relative frequencies. These now become the numbers on the vertical, and you can see we go up to about 0.4. So I'm going to put 0.1, 0.2, 0.3, and 0.4. Okay. And I'm going to do my bins just the same as I did before. 0.1, that's up. That's kind of a little bit closer to 2. Okay, this one's all the way up to 0.4, almost. And so is the next one. And then this one is 0, so there's nothing there. And then 0.56 is about halfway. Here we go. Okay. The thing is that your relative frequency histogram and your just regular frequency histogram come out looking pretty similar. Notice that the shape is pretty similar for both of these. And that's because you're just changing the scale. You're not really changing any of the values. Okay. So that's that one. It's a relative frequency. Another type of data display that we use is called a stem and leaf plot. And you've probably seen these before. We have our stem, and stem is usually the tens digit or the larger digit. And then the leaves are the ones digit in this case. This is the same data done as a stem and leaf plot. So this means 20 miles per hour or 42 miles an hour. Each one of these leaves is another data point. Notice that even though there isn't one in the 60s range, we still put that 6 so you can see the gap there. Once again, it does show that, and that shows you that it shows the features of the distribution. It does preserve the original numbers, and that's something unique with the, well, maybe not unique, but it doesn't happen on a histogram because you can't see, I don't know where that any of those numbers are between 25 and 40, but it does happen on a stem plot. And it does, but it's only really good for small sets of data. You don't want to put more than 15 numbers on a stem plot generally. Okay, there's a couple special kinds of stem plots. Also, the first one's called a split stem, and that's just what it says. I'm going to split the 10s into 2, and the 2s into 2, and the 3s, and the 4s, and the 5s, and I hope they all fit. 6s, and well, there's only one 7 anyway. Okay, so this point I would put the ones from 10 to 14 here, and of course those are the only ones, and then anything from 15 all the way to 20 would go here. So here I have 20, and 25 goes in my second half. 30 and 30 and 30 and 32 go here. 35 would go over here. And so would 39, 40, 40, 42, and 45. And this just gives us more cases or more bins. And sometimes it's a good idea to break it down like this, especially if you only have a couple decades of intervals, like you're going from 10 to 35. Well, then you can break it down into the split stem so that you have a few more bins to put things in. Okay. And it changes the distribution a little bit, but not a whole lot. Okay. The last type of stem plot I want to show you is a back-to-back. And that is when you would have two sets of data. Like I said before, like maybe I'm going to compare mammals to reptiles or something like that. And I'm thinking most reptiles are slower than mammals. So what I would do is those would go on the other side. So here's my normal one with my mammals, but here over on this side would be my reptiles. So I have maybe one that goes 10 miles and 11 and 12, and I've heard that alligators can go about 35 miles an hour when they're going their fastest. Kind of scary, and I would imagine some snakes are around there too. But this one I would read backwards. I would read, this is 10 and this is 12. Okay, and they're used to compare because you can see the sides, the different sides, the shape of the different sides, and compare. Maybe one's faster than the other, maybe one's bimodal and the other one has a normal distribution. And those are the things that you can see on a back-to-back stem plot. Okay, stem plots, frequency plots, or histograms are all for quantitative data. Some of our data is going to be categorical or qualitative. Those are things that are like I have here flavors of ice cream. So they are going to be on their own type of display. This one happens to be a bar chart. It still has the frequency on the vertical axis, but notice my bars don't touch. It's because I can't really say that chocolate goes into vanilla and vanilla goes into strawberry and strawberry goes into butter pecan. They are each their own individual thing. So that is why they have an individual bar. We'll talk more about categorical and qualitative data later in the course. So that about does it on data displays. See you in class.